So in this last session, we are going to discuss about how we solve nonlinear optimization problem using gradient descent optimization. And we are trying to implement the gradient descent optimization to solve some nonlinear optimization problem using Python, at the same time using MATLAB. Okay, so move to the whiteboard now. So coming to nonlinear optimization problem, as I said earlier, so for a nonlinear optimization problem, nonlinear optimization problem, so you have our objective function, whether minimizing or maximizing, our objective function should be a nonlinear function of your descent variable. So nonlinear function of your descent variable. For example, like you can choose it as a x square plus 5, let us assume. So I'm trying to minimize x square plus 5. So that means the value of x at which our objective function should be minimum. So that is our intention, our problem to explain the nonlinear optimization problem. So it's the nonlinear optimization problem because your objective function is a nonlinear function of x. And we are trying to solve this optimization problem using gradient descent optimization method to find the value of x at which you have function will be minimum. I took very small example to understand the gradient descent optimization method. So my suggestion is, when you try to understand some new concept, new algorithm, try to apply that new concept, new algorithm for a small problem. Once you understand the problem, once you understand the concept, then you go for the larger problems. But at the initial step, it's better to go with a small problem. That is my suggestion, generally what I'm following. So that's why here also, in order to explain the gradient descent optimization method, I choose a small nonlinear optimization problem that is called x square plus 5. It's a very small optimization problem. Even we no need to write a code and no need to do some mathematical analysis to solve this problem, because we know, by seeing that function, we know that the value of the function will be minimum at x equal to 0 and the minimum value of the function equal to 5, right? So we know the solution, but we try to understand gradient descent optimization method, how the gradient descent optimization method will work to solve this problem. So the procedure I'm trying to explain first. How the gradient descent optimization method will help to solve this problem, we will try to explain. So before that, first try to see how this function looks like. So if you observe here, so see, when x equal to 0, your function x equal to 0, your function equal to 5, somewhere here, function equal to 5. When x equal to 1, your function value equal to 6 somewhere. When x equal to 2, your function value will be 9 somewhere. So that means your function will be varying like this in the positive side. If you go to negative side, if it is equal to -1, again -1 whole square, 1 plus 5, 6, so somewhere here. And -2, that means -2 whole square, 4, 5 plus 4, 9, somewhere here. So this is how your function looks like. So this is called as a convex function. This is called as a convex function. So if you want to identify the value of x at which your function will be minimum, so using gradient descent optimization method, how it will work, we are trying to discuss now. So how it will work? So gradient descent algorithm, first step is, we are trying to initialize, we are trying to choose randomly some values for your descent variable in the set space. So this is called as the set space, and x is your descent variable and this is your set space. In the set space, you can choose randomly some value. You can choose any value from the -infinity to +infinity, you can choose randomly some value. Okay, let's assume I choose some value here. Let's assume I choose some value x equal to 3 randomly, and at this, x equal to randomly, at that point, so this is the function equal to this value. Hope you understand. So in the complete set space, you can choose any value for x. Now what the next step is, you try to find the slope of the function at that point. Try to find the slope of the function at this point. Slope is nothing but the first order derivative. See, I think you know about the linear equation, y equal to mx plus c. And if you want to find the slope m for this equation, you can calculate dy by dx, first order derivative, equal to m. That is called slope. So what you have to do is you have to choose some value in the set space at that set space at that point. So what is the value of the slope you are trying to calculate? You are trying to calculate slope at that point. Okay. Now what next is, once you calculate the slope value, what next task is, our goal is initially we are at this point. Our goal is to reach this point, right? So we are here actually, but our goal is here to reach this one, where slope equal to 0. Here slope equal to 0 because your tangent is parallel to your x-axis. Here slope equal to 0, whereas here slope equal to positive. Your initial point is here, but your ultimate goal is to reach here. Then what you have to do? You have to update the x value such that your point moves towards the negative slope. This is the negative slope side. This is the positive slope side. You try to move this point towards the negative slope side when it is a positive. So that then what happened? It tried to move toward the negative slope side, tried to move toward the negative slope side. Finally, it landed in this point. Finally, landed it in this point. Like that, it will work gradient descent method. So gradient will be slowly decrease, and finally it landed where gradient equal to 0 or slope equal to 0. For example, suppose if you choose initial value equal to -2 somewhere here. Suppose if you randomly choose an initial value equal to -2 somewhere here, then what you have to do? You have to calculate the gradient or slope at this point. You have to calculate the gradient or slope at this point. Now the slope is negative. Now you try to move the point toward the positive slope side. Then you have to move like this and finally landed in the 0 slope side. That means, so gradient descent algorithm procedure, the work will be like this. So you have to initialize some value of x in the set space and try to calculate the gradient or slope at that point. If that is in the positive side, you have to move it to the negative side. If the gradient is the negative side, you have to move it to the positive side. Then you can finally reach this bottom point where the slope equal to 0. So you have, if you are in the positive side, try to move in the negative side. If you are in the negative side, you have to try to move in the positive side. Then finally you will be landed in that bottom point where tangent is parallel to your x-axis where the slope equal to 0. So you have tried to decrease the gradient continuously until you reaches the slope equal to 0 or gradient equal to 0. So that process generally the gradient descent algorithm will work. So there is some limitations in the gradient descent algorithm because this gradient descent algorithm will works very well if it is type of convex function. If your object function is very highly nonlinear, somewhat difficult. If it's a simple gradient descent optimization method. Okay, fine. So hope you understand the main strategy behind the gradient descent algorithm. So now I'm trying to explain how step-by-step procedure for the nonlinear optimization problem. So first step is step 1, that is, so hope you understand. So you have to randomly initialize your decision variable x. Some value you have to randomly initialize. Some value you can randomly initialize your decision variable. So next step is step 2, that is, so what the next step anyone can tell, maybe based on our discussion here. So what will be our second step?
Slope will be identified.
So you need to calculate the gradient at that point. So let's assume random initialize the x value as x equal to x naught. Let's assume that x naught may be 2, 3, 4, infinity, -1, -2, whatever it may be, some value in the set space of x. Now at that point you try to calculate the gradient g value. That gradient you have to calculate, that's equal to, let's assume f is a function, object function you are trying to minimize. So you have to calculate the gradient dou f by dou x at this point x equal to x naught. At that point you have to calculate the gradient g. So next step is step 3. Next is, so we are going to update our initial value x. We are going to update the x value. Our decision variable we are going to update. So initially x equal to, later we have to update it, finally you are reaching this point. So we are going to update it. How we update this one? Your x value, that means updated x value equal to your initial x value plus some delta x. So delta x means how much step you have to take from here to here. That's called delta x. How much update you have to incorporate. That's called delta x. But how we calculate this delta x, that is important. So delta x is proportional to your gradient. Is proportional to your gradient. That means dou f by dou x. But you have to move in each direction If you are in the high positive slope side, you have to move toward the negative slope side. You are in the negative slope side, you have to move in the positive slope side. The direction you have to take care of it. That's why I have to choose the minus sign here. Sorry, minus sign I have to keep here. Minus dou f by dou x. If you are in the positive side, you have to move in the negative side. If you are in the negative side, try to move in the positive side. Then you are finally reaches to the gradient 0 position or slope 0 position. So delta x is proportional to minus dou f by dou x. It is very important for the ANN machine learning, whatever it may be. So maybe in the back propagation algorithm, day after tomorrow, our sir will explain some delta learning rule, Woodruff learning rule tomorrow. In that also you come to this point. So you have to update the destiny variable. In our machine learning, we can call it as the update the machine learning model parameter. So in machine learning model parameter are an optimization, destiny variable updation. Destiny variable value updation will be done like this. So it's proportional to slope. So distance variable is proportional to slope, but in the negative side, opposite side. If it is a positive, move to negative. It is in the negative, move to positive. Then only you will be coming to this bottom point. It is a proportional, but okay, this will tell in which direction you have to move. The positive slope, you have to move in the negative slope. If it is negative slope, it is moved in the positive slope. That will give the direction. And how much step length you have to incorporate, that will be based on your learning rate. There is one parameter in every gradient descent optimization, whatever the variants. There are the different variants in the gradient descent algorithm, like stochastic gradient, that's the basic one. And we have the momentum, we have the Nesterov accelerated gradient, we have the ADA grad, we have the ADAM, we have the ADA delta, we have the RMS prop. So various variants of the gradient descent algorithms are available. In every gradient descent algorithm, there is one hyperparameter that is called eta. Eta is called as the learning rate. That learning rate will help us how much step length that can be incorporated. So that is delta x is proportional to, right? So that's equal to some constant. I will keep the negative sign like this only. Some constant eta that is called learning rate and dou f by dou x at your initial value x equal to x naught. So this will decide. So here learning rate should be generally between the 0 and 1. So this learning rate will tell how much step length you have to incorporate in the while updating the model parameter or while updating the destiny variable. So eta value is lying between the 0 and 1. So what is the significance of the learning rate I will tell. But as of now, we are focusing on the fixed length, fixed size learning rate, Okay. Actually, after this ANN workshop, we are planning to conduct complete workshop related to the optimization, where we are using some strategies to update the learning rate. That's fine. We just don't think about that one. Whereas in this session, for this course, we are focusing on the fixed learning rate. That means eta is constant value, that value between the 0 and 1. Some value you have to randomly choose between the 0 and 1. So based on that eta value, we can calculate delta x. Based on the delta x, we can calculate the x value, update the x value. So x equal to x naught, say minus eta, okay. So minus eta into dou f by dou x at x equal to x naught. So this is called as your delta x. Hope you understand. This is called your delta x. So like that will be updated. Then what is the significance of this learning rate? What is the significance or what is the importance of this learning rate? We will see. So I want to say the same diagram what you wrote earlier. So this is your convex function. Let us zoom. Now let us zoom. My initial point is here. Okay. So just assume I'm taking the learning rate very small value. When I take the learning rate very small value, then your step length will be very small. So it will be updated, and finally reaches to your optimal point. That means when your learning rate is less value, near to 0, then your step length will be very small. Because your eta is very small, your step length will be very small. When your step length is very small, then it will take more number of steps, more number of iterations to reach your final point. It will take the more number of steps or more number of iterations to reach the final point. It will take the more time to converge. It will take the more number of iterations to converge. It is slow when you take the eta value very small. If you took the eta value very large, then what happened? Suppose let us assume your initial point is somewhere here. And if you choose the eta value very large, Then because of the large step length value, there will be because of the large learning rate value, your step length also will be large. Your step length will be also be large, means it will be step from here to here. Then it thinks that still I am in the negative slope side. So you have to take the from here to here, it will jump. So what happened? It skipped this optimal point because of the large step length. It skipped the bottom point or optimal point or optimal solution. Then what it think? No, I am in the positive slope side. I have to move in the negative slope side. Then it will move here and here and here and here and here. That is what happened. If you choose the larger learning rate, there is a possibility. I'm not telling that everything will be happening. There is a possibility that skipping this optimal solution may be happen, and also there is a possibility of oscillations of your solution around its final point. Oscillations of solution around this final point. So to overcome these limitations, we are going for the adaptive learning rate optimization techniques in the machine learning. We are going to discuss later, not now. But as of now, for this course, we are trying to understand with the fixed learning rate gradient descent algorithm only. We are choosing the fixed learning rate eta. So eta may be 0.1, 0.2 or 0.9, 0.8, some value between the 0 and 1 we have chosen. Fine. So now what happened? X was updated. Once X is updated, then what you have to do? So again, go back to your step number 2. Again, calculate the gradient at the new X value, and again update the X value. Again, go back to the step 2, calculate the gradient in the new X value and update the X value. This process will be repeated until any idea, until you reach this point where the slope equal to dou A by dou X equal to 0. Okay, but generally in machine learning case, we are following convergence criteria. So based on number of iterations as a convergence criteria we considered. So number of iterations, maybe while writing the algorithm, we will choose the number of iterations as 100 or 200 or 1000. So this process will be the step number 2, step number 3 will be repeated until 200 iterations or 100 iterations what you mentioned in the program. Maybe you have a doubt, sir, we are giving the 100 iterations, but maybe after 10 iterations it reaches this point dou A by dou X equal to 0. Then what happened? Nothing will be happen. It will be continued until the 100 iterations. You will be in this position only. It will not be updated at all. So what I mean to tell you is, suppose this is your objective function. It will be like this, and you set the number of iterations equal to 100. Initially you started here, first iteration, second iteration, third iteration, and fourth iteration. And the fourth iteration you reach this point. So for the rest of 96 iterations you will be here only. Don't think that you will be somewhere else, because your X will not be updated. Why? At the end of the fourth iteration you will be landed here where dou F by dou X equal to 0. So dou F by dou X equal to 0 means this will become 0. Plus this will become 0. There is no update. So it will be here only until the last 100 iterations is coming close. You have a doubt now, sir. For 4 iterations, it coming to the optimal point. For 4 iterations, if the algorithm is converged, what is the need of running for the 100 iterations? Because the point will be struck at that point only, it's not moving further. Then why you are going for the 94, 96 iterations? Because in case of the simple problem like this x square plus 5, that was happened in the 4 or 5 iterations. But in case of the high complex machine learning and deep learning models, don't expect you will get this point. So you will not reach this point. That's why we are trying as many as possible to reach this point. But don't expect you will get the same point always. That's why in machine learning or deep learning, we will keep the converging criteria as number of iterations rather than whether your models are updating or not. You can use that also. And dou F by dou X also. If the mod is not updating, if the slope equal to 0, then you can use the termination criteria as that like that only. But generally in the machine learning or in the deep learning, we will follow the convergence criteria. We will follow the training procedure for the maximum number of iterations only. We will set the 100 iterations or 200 iterations like that. We will try to run the optimization algorithm for those 100 iterations or 200 iterations. After end of those 100 iterations or 200 iterations, what are the value of X values we are getting? So we are using that. Okay. So hope you understand how this non-linear optimization or gradient descent algorithm will work. So I'm trying to explain with a small case study, and later I'm trying to explain the same thing in the Python, and I also explain same thing in the MATLAB, and later I will give one assignment. You are going to solve that assignment by writing the code in Python and MATLAB both. Okay, so now we will try to work on a case study. So my problem is I am trying to minimize f of x equal to x square plus 5. F of x equal to x square plus, I am trying to minimize f of x equal to x square plus 5. So as usual, so to solve this problem nothing but trying to identify the value of x at which your f of x value will be minimum. You are trying to identify the value of x at which your f of x value equal to minimum. Okay. I want to use this is a non-linear optimization problem because your function is a non-linear function of your decision variable. X square is the non-linear function of your decision variable, non-linear optimization problem. I want to use the gradient descent optimization method, GDA, gradient descent optimization method. So as we know, what is the step 1 for us for the gradient descent optimization method? Our step 1 is you have to initialize the x value. So you have random initialize x value in the set space. Some random value you can choose. Just I choose the random value x equal to 2. Any value you can choose. Randomly you can choose some value between the minus infinity to plus infinity. Some random value you can choose. So x equal to you have to choose. Now step 2 is, so you have to calculate gradient. So you have to calculate gradient g value, gradient of the function that is called as dou f by dou x at your initial value of x that's equal to 2. Dou f by dou x that's equal to at x, your initial value x equal to, right? At that x equal to you are trying to calculate the gradient. So what is the gradient of this function dou f by dou x? That's equal to 2 into x, where x equal to 2. So that means g value equal to 4. Your gradient value at x equal to 2, that's equal to 4. Next thing is step 3. What the step 3? So and one more thing, step 1, while initializing x equal to, at the same time you have to initialize your learning rate also. Just as choose the learning rate equal to 0.1. Just I am choosing the learning rate equal to 0.1. Okay. So when the learning rate equal to 0.1, now tell me what is the third step? Third step is we are trying to update my x value, x equal to x minus eta into g. G means dou f by dou x. Hope you understand. Eta into x equal to x minus eta into g. Okay. The g is nothing but the gradient value at x initial value, at initial x value. That means, so x equal the x naught, initial x value. So x equal to x naught, that means initial x value, previous x value equal to 2 minus what is the eta value I have considered as the 0.1 into what is the g value I considered gradient, that's equal to 4. Now what is the value now? See, so 2 minus 0.4, that's equal to 1.6. See how it will be happening. See, actually this is my objective function. I know at x equal to 0, I have the minimum value of the function that's equal to 5. I know it. But randomly I have chosen some value of x at x equal to 2. I have chosen. Now initially I have chosen x equal to 2. After first iteration, my x value going to the 1.6. That means it's trying to move towards the x equal to 0. It is trying to move toward the x equal to 0. That's why the gradient descent algorithm will work. Because, hope you understand, because I took the minus sign here. Why I took the minus sign? Because I had to take the negative gradient. So minus 0.1 into 4, minus eta into dou a by dou x, minus eta into g. So now it is coming from the 2 to 1.6. So later it may go to 1, later it come to the 0.5, later it come to the 0. Like that it will slowly come to your optimal position. Right? This is step 3. So once the step 3 is over, now what is our step? Now we are going to the, again going back to the step 2. So again go and calculate the gradient, that's equal to dou f by dou x. At x equal to, at what value you are going to calculate the gradient now? At what value you can calculate the gradient now? Here I initialize x equal to 2. At x equal to I calculate the gradient. Based on the gradient I updated the x value. Now again go back to the second step. Go back to the second step. Go back to the second step. Now in second step again you are going to calculate the g value. G equal dou y by dou x at x. At what x value you are going to calculate?
1.6.
Yes, at the now previous value you had to consider. That means previous value is 1.6, not this 2. So 1.6, so x equal to 1.6. So now this equal to, so dou y by dou x value, that's equal to 2x. So 2x at x equal to 1.6, that's equal to 3.2. Once that has happened, now go to the step 3. In the step 3, you are going to update your x value, x equal to x naught minus eta into g, or dou y by dou x. That's equal to x naught value. The x naught value means previous x value. So previous x value is 1.6 minus eta 0.1 into g. G means gradient. That's equal to 3.2. Now you have the 1.6 minus 0.32. 0.32. Now we have the 1.3 somewhere, 1.28, I think so, 1.28. Now see how it will happen. Initially you are x at 2. Later it come to the 1.6. Later it come to the 1.2. Slowly it coming and finally reaches to the x equal to 0 point. Because at that point we have the optimal solution. We know because we took the very small solution. Small problem I have chosen where the solution I already know. Now I am checking whether the gradient descent algorithm will work to find that solution. To find that optimal point, how gradient descent algorithm will work. We can visualize, if you choose a very small problem, we can visualize the algorithm, how it will work. So because we choose x equal to 2 somewhere, we know x equal to 0 is the solution, and slowly it is moving, and finally it reaches towards the x equal to 0 point, optimal solution point. So this process will be repeated. Again, go back to the step number 2. So again calculate the gradient. So this process will be repeated based on the convergence criteria. Generally, the convergence criteria what we set in the machine learning, that's equal to the number of iterations we want to run the algorithm. Okay, now we will try. Of course, you are able to understand the gradient descent algorithm, how it will work. I choose a very small problem. Now we are trying to solve it using the Python, and also we try to solve it using the MATLAB. And I give few case studies as a assignment. So try to solve those case studies using Python and also using MATLAB and upload in the Canvas later. Now we will see the implementation. So same, I already shared the code with you. So you can see somewhere, I think a Python file optimization. So click here again. And once you click on that link, so you are able to see this type of window. Here you can see open in Colab. So just click on open in Colab. Done. Okay. Thumb down. So this is a given, right? Now see the gradient descent optimization algorithm code. So here my intention is same. So I am trying to minimize f of x equal to x square plus 5. So where f of x is the objective function, x is the decision variable or control variable, which will decide the objective function value. Okay. Now, so what I'm doing, you can see here. So first, actually, in the Python, you can import required libraries. In the Python, we have some library called NumPy to deal with some numbers arrays, and we have pandas to deal with the data, and we have the matplotlib to deal with the graphics, plots, figures. So multiple, there is a math library to deal with some mathematical operations, mathematical performances operations. So here I am just importing the NumPy library and NumPy as NP. That means NP is like alias name. Sometimes if our name is very long, so people call us with some small name, right? So with nickname. So like that is also NP, alias name. So from next onwards, when we want to call this NumPy library, you can use NP instead of NUMPY, right? So why I am choosing this one is in order to randomly generate the initial value of x. So I think you know, right? So what is our first step? Sorry. So what is our first step? We are going to randomly initialize the x value. Okay, here I am choosing the randomly some 2 value. You can choose 3, someone choose 4, someone choose -5, like that. Any value you can choose. So that's why randomly chosen. So here I am writing a code x naught nothing but the initial value of x equal to np, that is the numpy dot random dot uniform. So there is a random number I am going to choose from between the -10 to +10. You can choose any boundaries. You can choose -infinity to +infinity, or you can choose the -100 to +100. Just I am choosing the -10 to 10 because I know the solution x equal to 0, right? Somewhere between the -10 to +10. I don't want to set some very long infinity value, either -infinity +infinity. It will take the more time. So we know the solution. That's why I took the -10 and +10 as the boundaries for the initial. So from this -10 to +10, you can randomly initialize the value for x, initial value for x. So this is your first step, right? You agree? So x naught is the initial value of x. Initial value of x means the value of x at which, initial value of x. You have to randomly choose some initial value of x between -10 to +10. So what next? So just here I am using eta, that's equal to learning rate eta. I am choosing the eta value equal to 0.9. That value chosen from the 0 to 1. Any value you can choose from 0 to 1. And of course, here I am using the epsilon value. So of course, it's not required. Forget. So here I am choosing the maximum number of iterations as a 1000, or you can use 100 also. So I am choosing the maximum number of iterations as 100. So that means I want to run this algorithm for the 100 iterations. I want to run this algorithm for the 100 iterations. Now start 0th iteration started. Now 0th iteration is started. Now up to here is the initialization. First is the random initialization of your variable. First is the random initialization of your variable. And second one is the initialization of your eta, learning rate. And initialize your number of iterations. How many number of iterations you want to run the gradient descent algorithm. That's how you can initialize. You can initialize your starting iteration as 0. You can initialize the starting iteration as 0. After that, I do small function. You can omit this also, not required. Okay, so you can omit that also. So you can call it as a function. So here I am using a small function. So define, I am defining a function with the name derivative. Derivative is the function name. And that function will take a variable called x. Then what it will return? It will return the x derivative. So it will return the derivative, gradient, dou f by dou x it will return. So then what the dou f by dou x value? We know, right? Already we calculated dou f by dou x equal to x. So that is the 2 into x. Okay. So that means your this function, this derivative function is used to calculate the derivative of your objective function and return it. Okay. So that's it. So next what we are going to do? Now this is the iterative algorithm. I am using the while loop in the Python. I am using the while loop in the Python. So while this loop will be iteratively executed until number of iterations reaches the maximum number of iterations. Until your current iteration reaches the maximum number of iterations, then the algorithm will be stopped. Until that loop will be executed. So what we have to do? So we are going to calculate the delta x. How we calculate the delta x? See, delta x. I think in the previous you can see here. Delta x. How we calculate the delta x value? Delta x equal to minus eta gradient, right? Derivative, right? Minus eta derivative. So same thing is available. Delta x equal to minus eta into derivative. This function I am calling. This function I am calling. This is a derivative function. Just I am calling this derivative function. So derivative of pass your x value. What the initial x value you have, that value you have to pass it. That x value you have to pass it. Now what it will do? It will give the derivative or gradient of your function at the x naught and multiplied with eta with minus sign. So finally it will give the delta x value. Delta x value means how much step length, how much change that should be incorporated in the destination variable. So once you got the delta x value, now update the x value. Update the x value. That means x naught equal to x naught plus delta x. X naught equal to x naught plus delta x. X naught equal to x naught plus delta x. But where you can see that one here. X equal to x naught plus delta x. That means that's what I am writing. X equal to x naught equal to x naught plus delta x. That means x naught will be updated. That's it. If it is previously x naught equal to, now 2 minus 0.4, now x naught equal to 1.6. If later it is 0.32, like that it will be updated, x value will be updated. That's what I mentioned here. X naught equal to x naught plus delta x. Fine. So after that, actually this is an iterative loop. This loop will be executed until iterations is less than the current iteration is less than the max number of iterations. If reaches the max number of iterations, it's coming out of the loop. But where the increment of the iteration will be take care of it. So just here I am taking take care of the increment of the iteration. That means iter equal to iter plus 1. Hope you understand. That means here the step we are updating the iteration count. So 0th iteration completed, next first iteration, next second iteration, next 199th iteration. Then 0 to 99 means 100 iterations. So once it reaches the 100, so 100 is not less than 100, so it is coming out of the loop. So this is the executed iteratively until 0 to 100 iterations, right? So now print solution x naught equal to, within the code, what you mentioned within the double quote, that will be printed as it is, comma, round, I am trying to round off it, nearest integer I am taking, round off x naught value. What is the x naught value you are getting, that x naught value taken here. Okay. So now simply, so this is the complete code. I hope you, once again, otherwise I will explain. So you have to call the required library here, and you have to randomly initialize the x value, randomly initialize x value between -10 to +10. You can choose any range, and you can initialize the eta value as a 0.9. You can initialize the max number of iterations as 100, and you can choose the iteration equal to 0, starting 0th iteration. Now you can use a function called derivative function. You can remove that also, no issue. Instead of keeping the derivative of x0, here you can write 2 into x0. That's fine. So you can use it, or if you don't want to use it, just keep 2 into x here. That's fine. Okay. But anyhow, to understand the function creation in the Python, just I am keeping that small section. So to define a function, derivative function name, x, the variable which is taking, the function is taking. Now what it will return? It will return x derivative. So x derivative value equal to 2x. Why? It's the x square plus 5. What is the derivative with respect to x? It is the 2x. That's the 2x. Okay. Now, so while iter less than max the number of iterations, that means this loop will be iteratively executed. So what is the loop will be executed? What are the iterations will be executed? One is you are going to calculate the delta x. So delta x equal to minus eta into dou a by dou x into x equal to x naught. So delta x equal to minus eta into derivative dou a by dou x at x equal to x naught. So that's the delta x, and you have to add the delta x to the initial value. So x naught equal to x naught plus delta x. Why took the minus n here? Because if you are in the positive side, you have to move toward the negative side. If you are in the negative side, you have to move toward the positive side, so that you will be landed in the 0th loop, that bottom point. Okay. So this is the code we are writing, and later we are going to update the iteration. So this update will be take care of initial iter equal to 0, iter equal to 1, iter equal to 2, iter equal to 50, iter equal to 60, iter equal to 70, iter equal to 80, iter equal to 90, until 99. This loop will be executed. Once it reaches to 100, it is coming out of the loop, because 0 to 99 means 100 iterations. Now finally, I am trying to print the solution. That's it. So simply you can click in this arrow button to run the cell. So the solution is giving as a x value equal to 0. X value equal to 0. You can see here. So x value equal to 0. We know x equal to 0. We have the minimum value of the objective function. And similarly, there is one more example also considered here. I think okay, this fine. You can easily understand. This one you can see here. So it's fine. If we have the multiple variables, what we have to choose? How we can deal with multivariable optimization problem, multivariable nonlinear optimization problem, how we can deal with this one, multivariable optimization problem. So what the multivariable optimization means? Now I will take the same case study somewhere. I will choose the what's called same example, or the example in country x square plus y square plus 10. So I want to explain that again. Sorry. So I want to explain, right? So my problem is, my nonlinear optimization problem is minimize f of x comma y, that's equal to x square plus y square plus some 10. So I am trying to solve this nonlinear optimization problem. So where the value of x and y, our function will be minimum. For this also we know the solution. I take the very small examples to make you understand how the algorithm will work. Okay. So we know the solution. When x equal to 0, y equal to 0, your function will be minimum. So when x equal to 0 and y equal to 0, your function will be minimum. So that's what we are going to find by in the gradient descent optimization method. So please, anyone can respond. As usual, what is our first step?
Initialize the variable.
So you have to initialize x. Here, previously, if a single variable, we can initialize the only x. But if it is a multivariable, you have to initialize the every multivariable. Every variable you have to initialize. So I'm initializing the x equal to 2 and y equal to 3 somewhere. Randomly I'm initializing. Okay. I'm using the x equal to 2 and y equal to 3. And also we have to read the eta equal to something 0.1 or 0.2 you have to consider. Eta value you have to consider. So next one is also you have to initialize max the number of iterations. So max the number of iterations also you can choose. Let us assume I am choosing the max number of iterations equal 10. Let us assume. Okay. Now what we did later, we of course, so we are choosing as a iteration equal to 0. Okay. And next step is that means we are in the first iteration, that is 0th iteration. So step 3. So here what we are going. So once you are initialize x and y values, we are in the 0th iteration. So in the 0th iteration, what you have to do? You have to calculate the delta x. So delta x is nothing but we are going to calculate the delta x, and also we are going to calculate the delta y. How we calculate the delta x now? Because we have to calculate the step length for every variable, not a single variable now. We have the two variables. You have to calculate the step length for the both x and step length for the y. You have to calculate. If it is 10 variables, for every variable you have to calculate the change in variable value. Hope you understand. So because here we have the two variables x and y, I am trying to calculate the delta x and delta y. How we calculate delta x value? That is the minus eta dou f by dou x at x equal to 2. Your initial value x equal to, okay, minus eta x equal to and y equal to 3. Don't at initial values x equal to and y equal to 3. At that point you have to calculate the gradient. So minus eta dou f by dou y at x equal to 2 and y equal to 3. Now what happened here? Eta value you consider the 0.1. So minus 0.1 multiplied by what is the dou f by dou x value? 2x. That's it. It is a 0. It is a 0. So 2x means 2 into x value 2. So that's equal to minus 0.4. And similarly, delta y equal to minus eta, that's equal to 0.1 multiplied by what is the dou f by dou y value? It is again 2y. So 2 into what is the y value? 3. 2 into 3. That's equal to minus 0.6. Minus 0.6. Hope you understand. So we're calculating delta x and delta y. So what next step? Step 4. So we are calculating the delta x and delta y. What the next step maybe? What we can do further? We calculate the delta x value and delta y value. So later.
Update.
Yes, we are going to update the each variable, each decision variable we are going to update. In the optimization, we call it as a x and y, call it as a decision variables, but in the machine learning, we can call it as a model parameters. Okay, when we go to the machine learning, then we can easily understand. So x equal to and y equal to 3. So update. So x equal to your initial x value 2 plus delta x. Plus delta x means that is the, I think, minus 4. Minus 0.4. So that's equal to 1.6. Similarly, update the y also. Y equal to your initial value of y 3 plus delta y value minus 0.6. So that's equal to 2.4. Okay. Now what we have to do is the first iteration, 0th iteration completed. So in the step 5, what you have to do? You have to update your iteration count. Iter equal to iter plus 1. That's equal to 0 plus 1. That's equal to 1. Now what you have to do? Step 6. You have to check for the convergence criteria. Convergence criteria means if your iter value is less than iter max or not. If your iter value less than iter max, if it is a true, then go to step number. If it is a true, if iter is less than iter max, so iter value equal to 1, iter value equal to 1, and your iter max equal to maybe 100 or 10. So it is a 1 less than 10. It is a true. Then if it is a true, where to go again? Which step we have to go when it is a true?
Step 2.
Step number 3 we have to move. We move to the step number 3. Again calculate the, we have moved to the step number 3. Okay. So again calculate the step 3. So step 3 means delta x calculate, delta y calculate. So delta x means minus eta and dou f by dou x, 2x. So 2x value, what is the x value now we have? I think x value equal to 1.6. 1.6. And here delta y equal to minus eta into dou f by dou y, 2y. So 2 into 2.4. Now you have the new delta x and new delta y values. What is the value? 2 into 1.6 means 3.2. That means minus 0.32. This one. And this one 48, 4.8. That means minus 0.48. So next step number 4. What is the step number 4? Updation. That means x equal to x plus delta x. So that means x value, what is the x value? Previous x value 1.6, delta x value minus 0.32. Now it is a 1.28. And what is the y value? Y plus delta y. So that's equal to what is the previous y value? 2.4. Here you can see the 2.4 previous y value. 2.4 plus delta x. What is the sorry, not delta x, delta y. Delta y value minus 0.48. So somewhere we have here. So you have the new x and new y values. Again, now first iteration also completed. Now again update the third, go to the third iteration, fourth iteration. Like that you are going to the until 10th iteration reached, and every time you have to calculate the delta x value, you have to update the x and y values. You have to calculate the delta x, delta y, and you are going to update the x and y values. That process will be repeated until you reach the maximum number of iterations. So how many number of decision variables are there in your optimization problem? Those times you are going to calculate the gradient, and those times you are going to update the model parameters. Hope you understand. So now we are trying to see the implementation of this one. You can see here. So multivariable optimization using the gradient descent algorithm. Multivariable optimization using the gradient descent algorithm. So my function is minimize x square plus y square plus 10. So dear participants, don't think that so these are the simple mathematics. Y is explaining all those things, because so these are the basics to understand the any learning algorithm that is used for the either machine learning or deep learning. So that is required actually. If we use any Python library or MATLAB toolbox, just we are using as a black box, that's it. We don't know what happened in behind. If really want to know the back-end mathematics for these models, this gradient descent algorithm is very useful. You have to understand it. You have to enjoy this one. That no, sir, we don't want to know what happened behind. Just we want to feed the input, want to see the output. If that is the case, maybe this information is not required. But if you want to know what happened behind of every machine learning model, then this mathematics is required somewhat. These are basics that will be required to understand the training procedure of the machine learning models. So when you discuss about the backpropagation algorithm, when you discuss about the withdrawal learning rule, in all the cases, again, this gradient descent algorithm will come into picture. Fine. So again, I am using required libraries. So that is, I'm importing the NumPy library. I am importing the math library. So I am initializing the learning rate as a 0.1. Here, what I am doing here, if you can observe here, I am initializing the both decision variables x and y. I am initializing the both decision variables x and y randomly between minus 10 to plus 10. You can choose anything. You can choose anything, but I am going for the minus 10 to plus 10. I know the solution x equal to 0, y equal to 0. I don't want to go for very infinity solutions. It will take the more time. And iter max equal to 100. Max number of iterations I have chosen as 100. And here I am choosing the iteration 1. If you choose from the iteration 0, then you have to keep here only minus less than. If I start from the 1, you have to choose less than or equal to. Okay? Hope you understand. Then that means that we have to run the algorithm for the 100 iterations. Now, I'm not using the functions anything now. You can see here. What I'm doing, y iter less than or equal to iter max. That means this loop will be repeated until your iterations equal to the iter max, 100 iterations, whatever it may be. What next I am doing? I am calculating the delta x. I am calculating the delta y. Delta x equal to minus eta derivative 2x. Delta y equal to minus eta derivative into 2y. Right? And x and y values are initially available here. That values are fed here. Later, what we have to do, once you calculate the gradient, with respect to x, gradient with respect to y. Next, we are going to, so not gradient, sorry, delta x of the x and delta y, change in step length for the y based on the gradient values and based on the learning rate, you will get these two. Once you got the step length for the x and y separately, then you are going to update the decision variables x and y like that, x equal to x plus delta x and y equal to y plus delta y. So this is x and y updation. Later, because in the while loop, that iteration, that variable will not update automatically. If it is a for loop, then for I equal to 1 to 100 means I equal to 1, I equal to, I equal to 3, internal increment will be happen, but in the while loop not happen, you have to specify it. So that's why in the while loop I have to specify the incremental. Iter equal to iter plus 1. That means first iteration completed, now move to second iteration. Second iteration completed, move to third iteration, like that. Okay. So this simple line of code will be useful for the complete gradient descent optimization algorithm. So just run this code, initialization, run this code for the gradient descent optimization. Done. Now I want to print the values. So what value of x and what value of y I am getting, right? So here what I am doing is I am trying to calculate the objective function. So objective function equal to, what is the value of the objective function? X square plus y square plus 10. So how we represent the x square in the Python, how we represent the y square in the Python? So there is the math library, empty. Math library, we represent as the empty. So you can see here how I represent the object function, empty dot power pass x2. That means it is called as x square. And empty dot power y comma 2 y square plus 10. So x and y values are coming from this cell. Updated x and y values are coming, and those values will be substituted here, and it will give the x square plus y square plus 10 value. This will give the x square plus y square plus 10 value. That is the objective. So I'm trying to print that value. Minimum value of objective function is. So these all are, keep it in the single quote. Text as it is. Just print as it is. Minimum value of objective function is. So outside the quote, I am keeping the obj. This obj will be printed. Or the obj value I am getting 10. That means minimum objective function value is 10. Will get at x equal to this x value, at y equal to this y value, what updated one. You can see the output, what the output I am getting now. So we know the solution is x equal to 0 and y equal to 0. We know the solution, x equal to 0 and y equal to 0, right? So see what happened here. X equal to, maybe you are able to make, maybe you see that 6.8 and something, but you can see here e power minus 10, that means 10 power minus 10, almost equal to 0. Okay, so here also y equal to minus 2.9 something into 10 power minus 10, that means it's also almost equal to 0. When x equal to 0 and y equal to 0, so I have the objective function value will be minimum, and that minimum value of the function equal to 10, because we know that already. I choose a case study where the solution is already known. So you call x square plus y square plus 10. When x equal to 0, y equal to 0, then the function will be minimum, and that minimum value of the function equal to 10. The same value will be coming here. So this is how we can use the gradient descent optimization method to solve the single variable nonlinear optimization problem or multivariable nonlinear optimization problem without constraint. So there is no constraints here. So why I am taking the nonlinear optimization problem without constraint, unconstrained nonlinear optimization problem, because in machine learning or in deep learning, we required it. In machine learning or deep learning, we required nonlinear optimization, unconstrained problems. That's why I explained the gradient descent algorithm for the nonlinear, multivariable, unconstrained optimization problem. Now this knowledge will be helpful for you even for tomorrow class only. Class also. With the basic information I am giving, maybe somewhat it will be helpful for you for the tomorrow class also. Sir maybe explain some introduction related to the ANN, and also later he will go for the different learning rules like delta learning rule, withdraw learning rule, perceptron learning rule, and competitive learning rule. Of course, okay, in competitive learning rule, maybe it's not up to the mark, maybe not useful at that time. But in case of the withdraw learning rule, in case of the delta learning rule, definitely this knowledge will be helpful for you to understand. Okay, so as of now, we discussed only a simple mathematics, and just I kept one second assignment. So here we are going to find the global minimum point for x to the power 4 plus 3x square plus 10. So you have to write the code to solve this problem, both in MATLAB and also in the Python. Okay, so only Python you can try. So because the time is already fine, we have still some time is there. So this is the thing you have to do actually first. So this is the second assignment. This is the objective function. You have to write the code to find the optimal solution. Optimal solution means the value of x at which your function will be minimum. Of course, we know when x equal to 0, your function will be minimum and the value equal 10. Now you write the code, see whether you are getting the same output or not using Python. Okay, hope you understand. Now I'm trying to explain the MATLAB. Some within 10 minutes I will try to close this one. I'm trying to explain the MATLAB now, this one. So GDA, this is the one MATLAB code. Already written and executed in the mat. I will explain this code. So I will save it as a GDA, gradient descent algorithm. Okay. So next, of course, here there is I'm using one function called derivative. See, in the Python also I am using a function called derivative, def space derivative of x, right? So similarly in the Python also I am using one function. That function also we are going to take here. So go back. You can see derivative dot-m. This is the gradient descent optimization derivative function. So this function also required. This is the function now. So open. So how we write a function in the MATLAB? Function. What that function returns? X derivative, y derivative equal to. This is the function name derivative. It take the two values x and y and return x derivative. So why it is a 6x? Our problem is, you can see, I think somewhere, I removed that one. I think maybe here actually my function is 3x square. Please give me some time, please. Where is this one? Otherwise, I will do small modification. Don't worry. Yeah, sorry. Coming to here, my problem is minimize 3x square plus 4y square plus 10. I'm trying to minimize 3x square plus 4y square plus 10. Now, what is the x derivative? What is the derivative of the function with respect to x? 6 into x. What is the derivative of the function with respect to y? 4y square derivative, 8y. So, those things are available here. 6x and 8y. Now, save this function with your function name. So, derivative, just save this one. Okay, so function is ready. Now this function is ready. It will give the derivative of x, derivative of y. Now coming to the gradient descent algorithm. As I said earlier, CLC to clear your command window, clear all to clear your workspace. So these all are the comment sections. Just this define about your problem. 3x square plus 4y square plus 10. Now coming to the initialization. So in initialization, I want to randomly generate x value and y value between the -10 and +10. I want to randomly generate x and y values between the -10 and +10. So lower limit is -10, upper limit is +10, and this is the code we have to use in the MATLAB to generate the randomly. So lower limit, plus randomly generate. Rand means rand is a function which generates the value between 0 and 1. Rand is a function which randomly generates a value between the 0 and 1 multiplied by upper limit minus lower limit. Hope you understand. So maybe if you confused, I will explain in the whiteboard. Yeah. So LO lower limit equal to -10, UO upper limit equal to +10. I want to generate x value between the lower limit and upper limit. What the code I am writing here? X equal to lower limit plus rand is the function value between 0 and 1 multiplied by upper limit minus lower limit. Hope you understand. Upper limit minus lower limit. Okay. Suppose rand value, I said that rand is a random value generated between the 0 and 1. I said that rand is a function which generates the value between 0 and 1. Suppose if it generates the 0, then x value equal to lower limit minus 10 plus random equal to 0, upper limit plus 10 minus into lower limit again plus 10. So the value equal to minus 10. That means when the rand value generated is 0, then you will get the x equal to minus 10. Suppose the rand value equal to 1. If the rand value equal to 1, then what happened? X equal to lower limit minus 10 plus rand value 1 multiplied by upper limit 10 minus into minus plus 10. Then what happened? You can see is the minus 10 plus 1 into 20, that's equal to 10. The maximum value will be printed. That means if the rand value is 0, lower limit will be printed x value, and maximum value is 1, then the upper limit will be assigned to the x value. If any value between the 0 and 1, then any value between the minus 10 and plus 10 will be assigned to the x value. That's how we can randomly generate a value between the lower limit and upper limit in MATLAB. So rand is a function which generates the value between 0 and 1. If the 0 generated, your x value will be lower limit. If 1 is generated, your x value will be upper limit. If anything between the 0 and 1, then the value of the x will be between any value between the minus 10 and plus 10. That is the logic behind this MATLAB code. So x equal to lower limit plus rand into upper limit minus lower limit. Y also I want to generate between the minus 10 10, lower limit plus rand into upper limit minus lower limit. Don't think that both x and y values will be same because we are writing the same piece of code so that you will get the x and y same. No, here rand is a value, maybe when this line is executed, your rand value may be 0.5. When this line executed, your rand value may be 0. Accordingly, your y and x value will be changes. So like that, we are going to initialize the x and y values. We are going to initialize the x and y values. Once your initialization of x and y values are completed, now what we have to do? You have to assign the learning rate, you have to assign the maximum number of iterations. And I am initializing a matrix with all zeros. I am initializing a row matrix, one row, 100 columns. I am initializing a random matrix F, one row, 100 columns with all zeros. Why I am choosing this one? I want to store the value of the objective function at every iteration. Only that is the purpose here only. Actually, it will not do anything for the gradient descent optimization algorithm. Only I kept this one for the plotting purpose. I want to save the value of the objective function at every iteration in the F matrix. That is the only purpose here, to store the information, to store the data. That's it. To store the values of the objective function at every iteration, I am using this matrix. Nothing happened to the gradient descent algorithm with that F. Now I am using the for loop instead of while loop for iter equal to 1 to iter max. That means this loop will be iteratively repeated until 100 iterations because I am giving the 100. So x derivative, y derivative equal to, you can call this derivative matrix, derivative function. So it will give the 6x and 8y. That 6x and 8y will be coming here. X derivative is the 6x, y derivative is the 8y. Now update the x and y values. X equal to x minus eta into x derivative 6x, and y equal to y minus delta x. Delta x is nothing but the minus eta into y derivative. So these are the helpful to update the derivative, to update the x and y values. Hope you understand. This is the updation of x. This is the updation of y. Updation of x equal to x plus delta x. So this is the delta x, 8 minus eta into x derivative, dou a by dou x. That is the eta. Sorry, delta x. And minus 8 into y derivative, minus 8 into dou a by dou y derivative, that is the delta y. So like that we are going to update the x and y. So after that, after updation, I am trying to calculate the objective function value and substitute in this matrix. See, this also nothing will do in the gradient descent algorithm, just only storing purpose, that's it. This only for the storing purpose, that's it. It will not do anything to the gradient descent algorithm. The gradient descent algorithm, mainly these three only, and iterative loop. This will not do anything, just storing the data, storing the information, storing the object function value every iteration. Okay, now this is the only printing. I want to print the x value, I want to print the y value, and I want to print the minimum value of the object function at which my object function will be minimum. And finally, I want to plot it. Just I am trying to run the code. See, initially my object function value somewhere 350 and slowly decreasing and finally landed over at 10. See, I am getting the objective function value 10 only. 10. So slowly it is decreasing. See, your objective function is slowly decreasing. Initially 338, 291, 251. Slowly it reaches to that minimum value 10. Minimum value 10. when it will be coming minimum? Optimum value of x equal to 0.02, that is equal to 0, and y value equal to 0. When x equal to 0 and y equal to 0, when x equal to 0, y equal to 0, my function will be minimum, and the minimum value of the function equal to 10. So this is all about the implementation of the gradient descent algorithm in the MATLAB. Hope you understand. So once again, go through this all the codes and try to work at home on the assignments. And if you have any questions, you can post it in the WhatsApp group, or you can call me to discuss in the tomorrow. Okay. So this is all from my side for today's session, and tomorrow sir will tomorrow Vinod Kumar sir will give some introduction about the artificial neural networks and some learning rules. And day after tomorrow, I will explain the back propagation algorithm, how neural networks will update their weights based on the gradient descent algorithm. Okay, of course, maybe there is one more thing. Maybe you can find it in the Jupyter notebook. Maybe it's not printed actually. This also I will cover in the day after tomorrow. Actually, just I explained linear optimization, non-linear optimization, and implementation in the Python and MATLAB. And I said that this optimization algorithms will be helpful to update the model parameters. But how the model parameters will be updated in the machine learning model, not discussed as of now. So that I will discuss on day after tomorrow. Later, I will move to the artificial neural network. So this is the section where you can understand how optimization is useful in the machine learning. So this will be discussed in the next class. That means on I think Thursday. So this is all from my side. And if you have any doubts, you can ask, or we will meet again. Of course, I will join tomorrow also, but my session will be on Thursday. And tomorrow, Vinod Kumar sir will tell about the introduction to the machine learning and introduction to the ANN and various learning rules. Thank you.
Sir, here one question.
Yes, sir.
Sir, here